Hey, it is Xaber once again, and in this video I want to show you how we can train and use a custom model which will be finding objects of different types on the screen. And for as our playground we will be using this game which looks like this. And this game is a basic clicker, so all you have to do is find different types of objects and click on them. And the main problem here is that there are many different types of objects. So as you can see, there are gold piles, there are wheel cards, there are some boxes, there are gems, and all other kinds of resources, and all of them look differently, and all of them could be looked at different angles. So classic methods like image search and color search won't cut it, and we will try to solve this problem by using a custom neural network which will teach to detect different kinds of objects, and I will show you the whole process. But let's look closer at what we have. On the right, we have a game. Well, not actually a game, it is a video player which runs pre-recorded session of a game. And on the left, you can see the end result. So we have a trigger called machine learning, which uses a custom neural network which we taught how to detect different kinds of objects. And as you can see, it can find a whole lot of different objects on the screen. It can find gold piles, boxes, it can find wheel cards, and all the other things which we taught it. And I will be showing you how we can get this result. Now let's focus on what we're trying to achieve. As I mentioned before, to get this result, we will have to get a custom version of YOLO, which will be able to detect new types of objects. At the very base, there will be a model called YOLO, you look only once, and it is probably the most famous model in the world which can detect different kinds of real-world objects such as buses, cars, different road signs, all of this stuff. And it can do it by default, so it was trained on millions of real-world images to get this, but it never seen screenshots from our game, so it does not know how, for example, wheel cards look like and how boxes with gold coins look like. So we will have to teach it. You can get this model from anywhere, so the method which I will be showing you is the one that I'm using and the one that I recommend, because yeah, that was the whole idea behind developing this tool, to make the training process a bit easier than it was. To EyeAuras, it doesn't really matter where you got this model from, so you could have trained it yourself, or you could have downloaded it, or you could have prepared it using some other tool, so not YoloEase, which we will be using, but some other different tool. It doesn't matter, so it is just a file which you can get from anywhere. But yeah, enough talking. Let's focus on what we are going to do. First and first, you have to have the program called YoloEase, and there is a wiki page that I have created for it, and there are download links which you can use, and also you have to do some initial installation. So after you will download the program itself, to make everything work, you will have to go through this page and install all the prerequisites manually. So it will include Python, it will include some packages for Python, and it will include the framework which we'll be using for training. And yeah, that's it. So after you will do all these steps, and most of these steps are basically required for any kind of training which you will be doing. So you can use YoloEase after that, or you can use Python scripts, whatever. Now the next step would be you download this tool from GitHub, and the tool itself is open source, so You can even do changes in the code if you want, but you have downloaded and started it. First and first, you have to click on New and create a new project. Name it however you like. The next thing that you will have to do is click on this link. And what this tool does is it basically glues together two other tools. The first one is CVAT, which is computer vision annotation tool, which is used for labeling, and labeling is basically just selecting objects on screenshots. And the other tool is, as I mentioned before, YoloEase, which is the actual model which we will be training. And this program allows you to combine this together. So we will be getting annotation data from CVAT and then train YoloEase using this annotation model. The first thing you have to do is click on this link and then register on this portal. I will skip this step because you just select email and all this stuff, nothing really interesting. And I will put my credentials in here, and then you click on login. If everything worked and you put in correct credentials, you will see this label stating that you have logged in. And the next thing that you have to do is go to CVAT and create a new project. Click on this plus icon and put in a new project. And you can put in any name. Then you have to add labels. And labels are just names of objects which you will be looking for. So in our case, we will be looking for gold, and then you can select any color. Then we will be looking for just generic box. Then some gems. Oh, and cards, of course it will be cards. Then you click on submit and open, and you can see that now we have an empty project with 4 labels in it. Go back to YoloEase, click on refresh, and then select this project in the list. So it should pick up names of labels which you have predefined before. And the next thing you have to do is add data source. Data source is just something with images. It could be video file, it could be folder with screenshots, any of this. In our case, we will be using a video as a data source. And I have added the video. Now the program goes through a list of frames and picks some of them. And it has selected about 800 screens. And the main idea is that we want to have as many different screenshots as possible. So with different backgrounds and different kinds of objects in these screenshots. We won't be doing the cleanup in this case, but it is usually a good idea to do so. Now switch to the second tab, which is called Trainer. And there is a written guide on how to use it. It is on this page, and it has a bunch of steps and describes what to do. The main idea is the following. We have a dataset which consists of 800 images at this point. And the idea is that we will be processing all of these 800 files in small batches. And let's start with just 8 files. Click on OK, then you click on Create Task. Wait for a few seconds, and it should take me to CVAT page. So CVAT is a labeling tool. All it can do is it can help you to label your images. And let me show you by example what I mean by labeling. We have some screenshot with a bunch of objects on it, and all you have to do is manually select object of some kind. So we have created 4 labels: gold boxes, gems, and card. And you have to label all of those images on the screen. For example, this is a gold pile, and then, by the way, I heavily recommend you to learn shortcuts. keyboard shortcuts for all tools which you will be using, otherwise labeling will take ages. Yeah, let's proceed. We have selected a single gold pile, and then, for example, we can label this box, and do not forget to change classes of the boxes. And yeah, there are shortcuts for it as well. It is usually Control plus either 1 or 2 or 3 or 4, and it will select corresponding label by index. This is box, and then we can select another box. And yeah, by the way, usually the fastest way of labeling the image is you label something. For example, I have started labeling boxes, and then you just proceed and label all boxes on the screen. And you do not have to be very precise, but try to label objects just as if you would be labeling them if you would explain it to some person. So yeah, this one I won't label, and I think that is it. That is all boxes, and we will repeat the same process for all other types of objects. So same for cards, and do not forget to change sizes of these bounding boxes for different types of objects. It really matters. And that is it. And I will repeat the same process for all other objects which I can see on the screen. And yeah, as I mentioned, you do not have to be pixel perfect in this case. Just roughly specify how objects look like. Usually the model can quite quickly start understanding how different objects look like. And if it wants, you can just feed it with more screenshots, and this will be enough for it to understand. And yeah, gems are last object which I can see, and let's select this card. And that's it. Now we can proceed to the second screenshot, and you have to repeat the same process for all screenshots in the batch. It can initially take quite a lot of time, but you will get a hang of it quite fast. And also, after we will get the first working model, we can offload some of the work by automatically labeling the objects in new images. So for example, after the first generation, our model will start understanding how cards look like, and it can automatically pre-annotate objects in new batches. And I will cut video here.
A few moments later.
Okay, labeling of the first batch is done, and it took me about, I don't know, maybe 5 minutes or something. And the labeling is far from perfect. In many cases, I just copy-pasted previous bounding boxes without any kind of resizing. Rule of thumb is you want your labeling to be as good as possible because it really heavily affects the quality of your model. But in this case, I think it will be enough. As soon as you have completed this labeling process, all you have to do is click on menu and finish the job, which will make it so the program, YoloEase, will be able to understand which batches have been annotated. So as you can see, right now we have a single task, which we have already marked as finished. So we have basically only 8 images on which we can train. So now let's kick off training process. Just click on start. And the program will contact CVAT and will download all annotations which have been marked as finished since the initial step. And then it will start the training process. Also, before starting training, it will also check that everything is configured correctly. Otherwise, it will throw some kind of exception. And in our case, there will be no exception. So I will just fast forward to the moment when we'll get results from this training. Okay, training is about to be completed. And as soon as it will complete, you can actually already use the model which will be thrown at you. So as you can see, there are some graphics, and I will explain what they mean later. But for now, let's just check what we got, and you can click on this button, which will open the folder with your model. And this model can be copy pasted into the program. So I have copied path to this model, and now let's just replace the model which I have used before with this one. It should be much worse. And yeah, as you can see, it can barely see cards and everything blinks, and it also cannot find gold. So it can see some piles, but not all of them. But that is the result which we got after only 8 screenshots. The stronger thing is in machine learning is that you can improve it over time. So for example, this model is of kind of bad quality, but we can just throw in some more screenshots at it and it will become better. And eventually it will be just perfect. So after something like maybe thousands of screenshots, it will be able to find objects faster and in a more efficient way than most humans. Yeah, so now the next step that this program is actually doing is it runs prediction on the whole data set. And this will allow us to reuse these results for next batches. So let's wait for it to finish. Oh, okay, prediction step has been completed. And as you can see, it took about 3 minutes to do object detection on 800 images, and it also found quite a lot of different kinds of objects. And you can click on the image to see what the model was able to find. And to be honest, it's quite cool because a lot of objects are correctly labeled. So the next step would be to do the next batch. So right now we have trained the model only on 8 images in total, which is definitely not enough. And now you have 2 options. The first one, you can just create a new task, which will just create a new batch of 8 images, and you will have to do the labeling manually. Or alternatively, you can click on this button, so you can enable a thing called active learning, and then you can enable automatic annotation, and you can use prediction results which you got on the previous step to pre-annotate those files which you will be going to manually review afterwards. For example, you can set confidence threshold to 90%, meaning that it will try to pick those objects which it thinks were detected correctly. Now you click on OK, and now you click on Create Task. So as you can see, some of the objects on the screen were annotated, and keep in mind that that is the first generation of the model. It is in quite a bad state at the moment. So as you can see, a lot of objects were not detected, and most of gold piles were not detected, but some of them were. So you will have to review these boxes manually, and you may have to change some of them, you may have to remove some of them. Eventually our model will get good enough, and all you will have to do is just review how it annotated the image and click on finish the job. This is like the end goal of this process. And let me just manually go through these 8 images, and I will manually annotate them. Okay, and now I have labeled the second batch. All I have to do is click on finish the job and save it, yes, and then click on skip. Now the program should detect that there are some new annotations, and it will download them from CVAT and will do the training. So now we will fast forward to the second generation of the model. The training is about to be finished, and at this stage the whole training process takes about 60 seconds. Eventually it can take tens of minutes or even hours depending on your hardware. And while prediction step is running, let's check the quality of the model we got on the second generation. And yeah, the same idea, just open it in the program, and yeah. So what is noticeable is there are much less blinking, meaning that the model becomes more stable, although it still blinks when there are some effects on top of the game objects. Oh, okay, prediction step has been completed, and you can check the results. Also, you can open the folder with those predictions and go through them manually. So, for example, you can open any image and just go through them, and this will give you a rough understanding of the quality of your model. And to be honest, this is probably where I will call it a day, because there is no more extra steps. All you have to do from this point is just either increase the size of batch or just do some more. So for example, we can use the latest model to do pre-annotation, and then we can create a task with 8 more files, and the quality of this pre-annotation will grow better and better. And at some point, all you will have to do is just scroll through the images, check that it is working correctly, and finish the job. And that's it. Depending on image quality, on how objects look like, it may take tens of screenshots, it may take hundreds of screenshots, and in some cases it may take thousands of screenshots. Fortunately, with pre-annotation, it is not really hard to maintain a model even with thousands of images, because at some point, as I mentioned, most of the work will be done automatically, and you will have to just review the results. Yeah, so thanks for staying for so long, and see you in the next video.